Great. Well, welcome. Today we're going to continue talking about vaccines. So we started on this topic on Tuesday, particularly emphasizing smallpox and kind of the history of vaccine development, but then also emphasizing in the case of smallpox how even after the scientific discovery was made, it took many decades for people to be able to produce the vaccine in large enough quantities and distribute it so that you could think about making an impact on global prevalence of the disease. And we want to talk about that same concept today in terms of polio, which is a vaccine that is both made and manufactured in a different way than the smallpox vaccine. And that will lead us into a discussion of sort of modern methods and sort of the spectrum of methods that are available now for vaccine development. The other thing that I want to do today is try to tie this discussion on vaccines a little bit more closely with what we talked about last week in terms of what happens inside your body when you receive a vaccine or when you're exposed to an antigen, and how the immune system actually responds to that. And so the question is, what happens after a vaccine is introduced into the body? And I want to spend some time on that before we talk about development of the polio vaccine. And so here I've just picked a couple of the pictures that I showed you last time when we were talking about cell communication in the immune system, because what happens after the vaccine is introduced into your body is that it initiates cellular events, and cells share signals with each other, and that leads to activation of a specific cell population. If we're thinking about a vaccine that produces antibodies, for example, that leads to activation of B cells, immature B cells, which do two things. They both proliferate, increase in number, and they differentiate. They differentiate from immature B cells into antibody-producing cells. And so let me go back to what we talked about last week and illustrate that a little bit more closely. So one of the things that happens is that certain cells within your body process the vaccine or the antigen. And we talked about that. We talked about host cells that are perhaps infected with a virus, displaying pieces of that virus, antigenic pieces of that virus, in the context of a surface receptor called MHC1, presenting that, and other cells in the immune system recognizing that this is a foreign molecule, but it's being presented in the context of a self cell, right? So because it has MHC1, your MHC1 on it, this T cell recognizes that it's one of your cells, but it has a foreign antigen associated with it. In this case, it might be a piece of a virus that's replicating inside this cell. Right? And so that's antigen presentation to this population of cells